let's talk about designing DevSecOps pipelines. There are a lot of pitfalls and concerns to be aware of when designing pipelines. You really need to make sure that the pipeline is effective. The results, you would need to test to make sure that all the testings, you're not just getting a lot of false positives or false negatives or inconclusives. Otherwise, it's a big waste of time. So the accuracy of results, whether it's build results, test results, integration results, all of those things need to be, working with precision. Be aware of pipeline bloat. So don't just add a bunch of tools if you don't need to. There's a tendency to overdo it. So at any one point in time, have just enough tooling for the level of maturity that you're at. Usually it's not a, all or nothing. You build up your pipeline capability over time, starting typically with having a good CI process and then add C delivery and then deployment. So don't get too worried about adding all of those tools at once. It can be chaos. Unattended pipeline. So who's responsible for the pipeline? If that's not clear, that can be a big problem. As you get more people dependent on the pipelines, the maintenance and support of the pipeline itself becomes critical. And vulnerable pipelines, so hard-coded credentials. The pipeline itself can be a source of security leaks or security gaps. So don't just look at the application code from a security point of view. You should look at the pipeline tools and so on as well. They're some of the most public and embarrassing and costly security breaches have been of that nature, where the bad actors were able to get into the pipeline tools and take advantage of things like unauthorized access to gain access to the code, and then introduce malicious code into the application, and then the application gets deployed to their clients, and the problem expands across their whole client base. So this is a very important one, to secure the pipeline itself. Planning is something needed. You don't just run off and build a pipeline without properly, deciding what you're going to do and having an architecture. Make sure that you have experienced people building your pipeline architecture, as well as some stakeholders, including security and business owners. You want to make sure that everybody's expectations are built into the pipeline. Make sure everybody know what the outcomes are, the outputs and outcomes, so that you know what information the different stakeholders care about and expect to get out of the pipeline, to make them feel comfortable that the pipeline itself is working, as well as the applications. Otherwise, it can create a something that's not transparent and a lot of concerns, especially as you start accelerating deliveries through the pipelines. You want to make sure everybody's got the visibility that they need. The pipeline itself, for example, should have things like notifications to emails and dashboards and chat ops if there are issues with the pipeline. Should be automated means to get that information out there so that you can respond quickly. As the pipelines become more of a critical operating resource, they have to be treated as something that needs to work 24/7, or else it can affect the entire organization. All the developers and so on might be, unable to work if the pipeline's down. Check the health of the pipeline proactively. Maybe have some probes and synthetic monitoring going on. Status should be visible. Any agents that are being used as part of a synthetic testing, for example, could be built in. Keep an eye on capacity and other factors that may affect the pipeline. I recall one time we weren't monitoring the life cycle of some of our memory, and they overran the number of cycles on some of the semiconductor memories. We exceeded, and things started to fail because we weren't, and that caused a problem. We weren't tracking essentially the warranty period on the memory. So it's an example of something you want to keep an eye on, or you may have problems with your pipeline that become difficult to determine what's going on or prevent. And the architecture itself, architecting at the level of, the machines, physical machines, containerized applications, If you're using a platform as a service model in the cloud, you have to decide what architecture you're going to deal with the different layers in your tech stacks for the pipeline itself. So let's talk about planning a DevSecOps pipeline. Thinking about the outcomes is a good way to start. What is it that you're trying to produce? And then work backwards to say, okay, how do I build it? So make sure you understand what the technology and framework stacks are that are compatible with your applications. What are the dependencies? Make sure you cover any dependencies. Make sure, for example, when you're selecting tools, that they're ones that will work well together. It's certainly possible to, some tools work better with some frameworks than others. Don't forget non-functional requirements, things like performance testing, compliance testing, security testing. So all of those things need to be considered and prioritized. Approved tooling. So you have to choose what kind of tooling you're going to go for. Maybe vendor licensed tooling, or maybe open source tooling, or in some cases even do-it-yourself tooling, if it makes sense to do that. Sometimes it does, for the reasons of usually the best reason is if you have something that you want to have as kind of a competitive advantage, not just because of cost, because you are going to have to maintain anything you build yourself for a long time, and it doesn't necessarily work out to be cheaper in the long run. But maybe, if you're lacking some budget in the short term or something, it might be a solution as well. Build time. So, bear in mind things like, do you have a target for, let's say, the lead time for the CI process, CD, or deployment? Some tools are faster than others, or maybe they can scale horizontally better than others. These are all factors when you're choosing tools and technologies and architectures. And there are others. This is just an example of a simple DevSecOps pipeline using Azure DevOps. In general, these DevOps platform tools such as Azure DevOps, they help you configure jobs. Like, okay, a build job may have lots of parts to making a build for an application. Usually there's a lot of different parts of the build job. It may not be just a simple line of code by any means. It may be calling up all kinds of things to make the build for that application. And when the builds are done, then it will automatically launch some testing. Usually if it's CI level, then they're more like integration testing, or maybe some functional, some non-functional tests, but usually a limited set. And then once that's done, then you've got a release candidate, and maybe you automatically trigger the delivery phase, so staging with a lot of other kinds of tests, maybe in parallel. And finally, if you're doing automated deployment, when all that's working, then automatically deploy to different deployment environments. So it's an oversimplified diagram to show all of the major things in the value stream, from building, testing, CD, and deployment. But it can actually look that simple at an abstract level in these tools, and a lot of the details are buried underneath these different jobs. Okay, similarly for Jenkins or some of the other tools, they have a visual way of programming that way. Pipeline tasks, with minimalist security checks, is maybe you got some applications that you're not really that concerned about security, but maybe some things. So you can use some off the shelf or open source tools that don't have expensive licensing fees or something. So these are just some examples. There's quite a lot of tooling out there. I mean, literally, I would say thousands of choices for different tools. So choosing which tools to use, one of the factors is going to be budget. Generally speaking, the more expensive tools have a lot more capabilities, but if you've got an application you're not really that concerned about, then maybe the simpler tools that are lower cost will do the job.